Egypt has captivated scientists for centuries with its cultural and architectural marvels. Among these, the most renowned are the three giant pyramids located on the Giza Plateau near Cairo. These pyramids, whose builders, timelines, and purposes have long intrigued academics, pose the persistent question: how were they constructed? Despite various theories on how ancient architects processed and moved the massive stone blocks, no solution has proven entirely satisfactory. Many attempts to replicate the construction methods have failed. However, in the mid-20th century, chemical engineers made a discovery suggesting a new explanation for pyramid construction technologies. Independent examinations of building stone samples confirmed this theory, which could have been groundbreaking. Yet, the scientific community largely ignored these findings, and Egyptologists continue to overlook them. Egypt remains a haven for historians, archaeologists, art critics, and tourists alike, with its vast stone sculptures, ancient temples, and mysterious hieroglyphs. However, the primary allure lies in its pyramids, over 80 of them stretching along the Nile for 50 kilometers. Dominating this ensemble are the monumental pyramids on the Giza Plateau near Cairo, particularly those of Cheops, Khafra, and Menkaure, which were included in the Seven Wonders of the World. The Great Pyramid of Cheops, standing over 140 meters tall and comprising more than 2 million stone blocks each weighing between 2.5 to 15 tons, still puzzles scientists. How did people centuries ago manage to build such colossal structures? Egyptologists have proposed numerous construction techniques for these pyramids and have attempted to test them. These attempts, made by Americans, Japanese, and others, have involved constructing mechanisms like wooden structures with complex rope and pulley systems to move and lift the blocks. However, all these practical efforts, even when simplified, have consistently failed. The challenge was not just with relatively small blocks but also with colossal stones weighing up to 500 tons, such as those found in the Sphinx Temple at Giza. Theories about moving these blocks, such as using rollers, raise significant doubts. Even today, transporting such massive stones would be an extremely difficult technical challenge. Jean-Philippe Lauer, a prominent Egyptologist, proposed moving the stones on rollers, but this method seems implausible. The idea of lifting these blocks with wooden mechanisms also faces skepticism. Another theory suggests building earthen ramps around the pyramids to drag the heavy stones, while Albert Carlson and others argue for using wooden mechanisms. A notion that the pyramids were constructed from the top down, carving them from solid rock and then encasing them in stone blocks. Despite these theories, the construction methods remain highly labor-intensive and leave many questions unanswered. The architectural mysteries of ancient Egypt persist, awaiting further discoveries. All the stone blocks in the walls of the pyramids, both the smallest and largest, are almost perfectly fitted together, with gaps between some blocks being no more than half a millimeter. This precise alignment is seen not only in the Great Pyramid of Cheops but also in other structures, where the granite blocks meet at perfect right angles. Achieving such precision required more than just diligence, it necessitated specialized tools and advanced stone processing technologies that even today seem remarkable. How did the Egyptians achieve this level of adjustment? Scientists are left perplexed, continuing to marvel at the ancient civilization's greatness. In some cases, the construction techniques seem almost absurd. For example, in the Temple of the Sphinx, an inner corner is not formed by joining two blocks, as typical in stone construction, but by carving the angle into a single block. This involves a laborious process of removing part of the block's surface and then intricately bending it around the corner, a technique unheard of in traditional stone masonry. This raises the question, why did the ancients complicate an already difficult task? Even the authors of various theories acknowledge their inconsistencies. Serious scientific literature sometimes resorts to fanciful explanations, suggesting that the ancients used mystical methods to levitate and move the massive stones. Others propose that advanced civilizations, such as the legendary Atlantis or even aliens, might have been involved in the construction. What if we consider an alternative approach? If ancient architects couldn't cut and stack huge stone blocks, might they have used a different construction technology? In modern times, structures of similar scale, like skyscrapers, are primarily built with concrete. If the pyramids were constructed today, concrete would likely be the primary material. The blocks of the Egyptian pyramids resemble concrete in appearance, but producing concrete requires sophisticated modern technology. Cement, the main component of concrete, is produced by crushing rock, mixing it with water to form a liquid mass, heating it in kilns to around 1,500 degrees Celsius, and then grinding the resulting clinker into a fine powder. It seems unlikely that the ancient Egyptians had the capability to produce such concrete. However, throughout history, humans have used various materials similar to concrete or cement in construction. Different cultures used ingredients like lime, egg whites, wax, wheat flour, sheep cheese, and garlic juice as binding agents. These materials were not typically used to manufacture blocks but rather to fasten them together. French chemist Professor Joseph Davidovits of the University of Picardie-Jules Verne in the mid-20th century developed a method for creating geopolymer concrete, which does not require sophisticated modern technology. This type of concrete can be made using crushed rock and hardens quickly at room temperature, turning into an artificial stone. Davidovits' discovery utilizes the adhesion phenomenon, where dissimilar materials stick together at points of contact. He proposed that the ancient builders might have known this technique and used it to construct the pyramids. Davidovits boldly hypothesized that the pyramids and other famous structures in Egypt might not be made of natural stone but of a form of ancient concrete. This hypothesis, if true, would revolutionize our understanding of Egyptian construction techniques and explain the incredible precision of their stonework. To create artificial stone from hard rocks like granite, a binder is essential. However, no binder is needed if using soft rocks that can be easily ground into a fine powder. By crushing any rock to a specific size, then grinding it into a powder and mixing it with water, one can produce a stone nearly indistinguishable from natural stone. Ancient Egypt had the conditions necessary for manufacturing concrete. Interestingly, there is an ancient Egyptian image on the tomb walls of Rekhmire in the Valley of the Nobles that seems to depict the concrete manufacturing process. It shows two Egyptians collecting water from a reservoir, crushing rock, mixing it, and loading the resulting mass into a basket, followed by the creation of a large block. This suggests that the ancient blocks might not be natural stone but rather geopolymer concrete. This conclusion is supported by the observation that the composition of these blocks differs slightly from natural stone, leading to surface peeling that reveals sand underneath, indicating a synthetic rather than a natural origin. Consider the mysteries of the pyramids in light of the concrete theory. Ancient Greek historian Herodotus, often called the father of history, offered an account of pyramid construction after visiting Egypt and speaking with local priests. He described a method of raising stones using platforms made from short beams, suggesting that the stones were lifted step by step with the help of these platforms. Although vague, his description aligns with the use of wooden formwork for pouring concrete. Herodotus' account becomes plausible if interpreted as describing wooden formwork for casting concrete blocks. Formwork, a temporary structure into which concrete is poured, shapes the concrete until it hardens. Careful reading of Herodotus' text reveals that he may have been describing such formwork, used to gradually build up the stone layer by layer. Evidence supporting this includes the layering visible in pyramid blocks, which contrasts with the even, parallel layers seen in natural limestone. A fragment of a block from the Great Pyramid of Cheops shows a distinct mesh pattern on its surface, likely from the mat used inside the formwork. This pattern indicates that the blocks were cast in place rather than quarried and transported, supporting the hypothesis that ancient Egyptians used a form of concrete in their construction techniques. It appears that there were mats laid from left to right and another layer from right to left, creating a two-layer covering. This arrangement would be possible only if it were part of the formwork, where the mats covered the concrete. The top surface of the block is uneven and lumpy, typical of how concrete hardens. Today, special vibrators are used to avoid such defects, but it is unlikely that ancient builders had access to such technology. If the blocks were natural stone, their surfaces would be uniformly treated, indicating they were worked by tools. Therefore, it is likely we are dealing with concrete. The lack of attention to these patterns can be explained by their absence in the lower masonry, which tourists usually see. However, similar marks can be observed higher up, above 50 meters, suggesting consistent use of this technique at those levels. These blocks are comparatively soft, with hardness similar to plaster or bone. Sandstorms could have eroded the surface over time, masking any traces of their concrete origins. Sand acts like emery stone, only affecting the blocks up to 20 to 50 meters high. However, the mat marks are found higher than this and are not exclusive to pyramid blocks. For example, in the temple courtyard at Saqqara, some stones still show traces of reed mats used in their formation. Considering another mystery, how were blocks fitted with minimal gaps? In many places, the gaps appear as mere scratches on the stone's surface. Egyptologists don't have a clear explanation for this precision and can only admire the ancient craftsmanship. It's hard to imagine aligning multi-ton stone blocks so precisely. The blocks had to be cut from solid pieces of rock, which Egyptologists claim was done with copper saws. Yet, cutting wood with a steel saw inevitably results in uneven cuts. Copper saws would jam in stone without a way to spread the saw teeth. No copper saws have been found in museums, suggesting an alternative technique was used. If the blocks were not cut but cast in place, everything falls into place. Each layer was formed by pouring concrete into wooden formwork, creating new blocks that merged seamlessly with the ones below. Builders could have made the walls monolithic, but this would cause structural failure over time due to temperature changes and internal stresses. Dividing the pyramids into separate blocks allowed the structures to breathe and remain stable over centuries, without cracks appearing in their walls. Unexpected findings support the concrete hypothesis. For instance, a subsidiary pyramid south of Menkaures pyramid in Giza has a strange cavity composed of blocks with a hard crust but a different internal composition. This heterogeneity is typical of concrete, where a cheaper mix is used internally and a stronger, more durable mix externally. The surface layer of one block can be broken by hand, revealing a soft interior that crumbles easily, whereas the outer crust is hard and porous, resistant even to a knife blade. Natural stone does not have such properties. A hard crust with a soft interior is impossible if quarried and worked stone is used. If the blocks were concrete, it makes sense that substances were added to the surface layer to increase its strength. This raises the question of why these observations have not gained more attention. It is partly because the traditional view holds that limestone blocks were quarried and transported across the Nile, as depicted in documentaries, and this narrative has overshadowed alternative theories like the concrete hypothesis. In the blocks of the Cheops pyramid, even the size of a small coin does not show any signs of organic remains, and no cracks can be found despite the extensive search. This is because concrete is amorphous, preventing crack formation and behaving uniformly in all directions. Inside the Cheops pyramid, there is a monolithic granite sarcophagus, yet no one knows how it was placed there. The passages and doors are too narrow to have accommodated it. Similar mysteries exist elsewhere, such as in the Valley of the Kings, located 500 kilometers from Cairo near Luxor. Today, a wide road allows easy access, but a century ago, the valley was surrounded by steep cliffs and accessible only through a narrow, rock-hewn passage. When the first French explorers led by Napoleon arrived, they were astonished to find granite sarcophagi inside the tombs, which were too large to have fit through the only entrance. These sarcophagi were monolithic and rang like a bell when struck, indicating they were not assembled from parts. It seemed improbable that they had been dragged through the mountains or lowered with ropes. A more plausible explanation is that these sarcophagi were created in the valley itself using geopolymer concrete. This method could create artificial limestone, granite, or even super-hard diorite. Joseph Davidovits proposed that pyramid blocks might not be the only ancient Egyptian concrete products. This imitation of natural materials could have been used extensively in creating temples, statues, and household items, solving another puzzle related to artifacts found in the Djoser pyramid. Among these artifacts are amphorae made from extremely hard stone, such as diorite. Modern sculptors avoid working with such materials due to their hardness, even harder than iron. The question arises, how were these amphorae made? Egyptologists suggest that the Egyptians shaped the stone externally and then drilled it out using copper tools or stone. However, this theory is implausible due to the difficulty of drilling such hard materials and achieving the uniform thickness and smoothness observed in the amphorae. Davidovits' theory of geopolymer concrete offers a rational solution. Unhardened geopolymer concrete could be shaped on a pottery wheel like clay, allowing ancient craftsmen to produce these vessels efficiently. This process would explain the uniform thickness and smooth surfaces of the amphorae, demonstrating that the ancients had a sophisticated method for creating such artifacts. Another intriguing fact that captivates many Egyptologists is the precision and depth of hieroglyphs carved into the hardest rocks. The ancient Egyptian method of carving has no equivalent anywhere else in the world. In contrast to European or Russian stone carvings, where patterns appear at different angles with convex depressions and shadow edges, Egyptian carvings are distinct. They are cut at right angles, deeply and flatly, even in the hardest materials like granite and diorite. Tools made of hard alloys struggle to achieve such precision, yet ancient chisels, in the hands of skilled artisans, seem to face no resistance and remain steady even when encountering denser inclusions. It is puzzling why ancient craftsmen would carve hieroglyphs deeper than 10 centimeters when a depth of 2 to 3 centimeters would suffice for readability. Instead of attributing this to their perseverance and skill, a more plausible explanation might be that the hieroglyphs were not carved but extruded onto the surface of not yet hardened geopolymer concrete. This method aligns with the Egyptians' known expertise in plastering, as seen in their perfectly applied temple walls. This plaster was often mistaken for solid stone, but it was actually a cladding that matched the underlying material precisely. This perspective explains the bald spots on many Egyptian sculptures, where parallel layers of treated surfaces have peeled away, revealing the internal structure. Creating large statues, like a granite sphinx, would not require high-quality concrete for the internal parts. Another piece of evidence supporting the concrete theory is an ancient Egyptian granite slab found in a Hungarian temple. The slab, which crumbles easily, consists of granite crystals held together by sulfur powder, a clear sign of a manufacturing defect by ancient standards. This artificial granite can be easily broken by hand, unlike natural granite. Moreover, it's essential to consider how the ancient builders crushed rocks. One plausible method, similar to grain grinding with a mortar and pestle, involved using stones to crush other stones. By placing one stone on another and striking with a third, they could reduce even hard rocks like diorite to a powder without introducing iron from tools. This simple technique could produce the raw material needed for creating artificial stone items of any hardness and in any quantity. ancient Egypt thus provides a comprehensive explanation for many of the pyramids' mysteries, as well as other enigmatic structures like Baalbek in Lebanon and Stonehenge in England. These structures might have been constructed using similar methods, offering a rational solution to their enduring mysteries. If geopolymer concrete was indeed used by ancient civilizations, why did such unique knowledge vanish over time? The answer lies in the secrecy surrounding ancient discoveries. In the past, only a few select individuals knew these secrets, which were closely guarded. If these few initiates died without passing on their knowledge, the skills and production technologies were lost, much like Damascus steel. While we still know something about Damascus steel, or at least have heard of it, we have no known records of the unique construction materials used in the past. Why is there no historical reference to these materials? We are aware of the philosopher's stone from the Middle Ages, which was a major pursuit of alchemists in the 17th, 18th, and 19th centuries. The search for the philosopher's stone was extensive and complex, intertwining various stories. Traditional science sees alchemy as a precursor to modern chemistry, with contributions like mineral and vegetable paints, glass, enamel, metal alloys, acids, alkalis, and salts. However, the primary goal of alchemy was to obtain the philosopher's stone, believed to transform base metals into gold. It seems improbable that a science based solely on fiction and empty promises could have persisted for so long without yielding any real results. Alchemists were likely attempting to solve practical problems, and those who funded their research must have had good reasons to believe in the feasibility of their goals. There is a legend in alchemy about the secret of the philosopher's stone being last known in Egypt. It tells of a Roman named Marianus who possessed this secret knowledge. The legend recounts that the Egyptian king Colitis, frustrated by the failures of his alchemists to produce the philosopher's stone, was eventually assisted by Marianus, who succeeded and saved the lives of the other alchemists. Marianus later fled, fearing for his life, and was eventually found by one of the king's servants. When asked to reveal the secret, he gave cryptic instructions that subsequent alchemists failed to interpret. If we consider the possibility that this legend refers to the production of geopolymer concrete, it sheds new light on many ancient texts. Old alchemical books often describe methods resembling the production of concrete, grinding rock, adding special substances, mixing, and eventually producing stone. Artificial stone was a term used broadly to describe any manufactured stone, which could have been the philosopher's stone, created through knowledge and art. Geopolymer concrete would have been a significant invention, crucial for building strong fortress walls and other structures. Its loss would have prompted numerous attempts to rediscover it, but medieval alchemists ultimately failed. It wasn't until the 20th century that the hypothesis was revived by researchers like Davidovits, Fomenko, and Nosovsky. Their bold hypothesis needs independent verification. To definitively determine whether the pyramids were made of natural or artificial stone, a physico-chemical analysis is necessary, which has already been conducted by some researchers. In November 2005, a research team from the New Chronology Project, led by Gleb Nosovsky, visited Egypt. During the trip, they uncovered new facts supporting the concrete hypothesis, many of which are documented in this film. Additionally, they collected samples of the building material from one of the three Great Pyramids, specifically the Pyramid of Menkaure. The base of the pyramid, up to about 1/3 of its height, is lined with what is considered natural granite. A fragment of this lining was provided by Nosovsky for research. The sample was given to experts for analysis. Although the stone appeared very similar to natural granite and not at all like concrete, the examination results were eagerly anticipated. The analysis was conducted at the Institute of Physical Chemistry and Electrochemistry of the Russian Academy of Sciences. The goal was to study the stone's structure and elemental composition. A sample was prepared using a chipping method, followed by the application of an electrically conductive element, carbon, in a vacuum to create a thin carbon film on the sample surface. This prepared sample was then examined using a scanning electron microscope equipped with energy and wave dispersive X-ray detectors, which can determine elemental content with high accuracy. The study provided microphotographs of the sample's surface at different structural levels and X-ray spectra that clearly identified the sample's elemental composition and their quantitative content. Chemical analysis revealed unusually high levels of titanium, calcium, sodium, phosphorus, sulfur, chlorine, and aluminum, while potassium and silica were lower than typically found in natural granite. The appearance of the sample closely resembled granite, but an experienced geologist, upon viewing electron microscope photographs, would immediately recognize it as non-natural. Natural granite has a dense, uniform granular structure, with feldspar crystals embedded in solid quartz. However, the sample from the pyramid of Menkaure displayed a loose structure with unevenly spaced mineral grains held together by a binding composition, atypical of natural stone. This binder's presence could explain the elevated levels of certain compounds. These findings strongly suggest that the pyramid of Menkaure is lined with an artificial material. Moreover, close inspection of the photographs reveals another compelling argument for the concrete hypothesis: the presence of hair-like aggregates and individual hairs, indicative of foreign organic material. These could only have been introduced during the production of this artificial building material, possibly from animal fibers such as wool or hair, which are visible even under normal magnification. The significant amount of foreign material in the pyramid stone confirms it is artificial. These results align with similar conclusions reached by Davidovits, who conducted decades of research in this field. It is surprising that Egyptologists have largely ignored such findings despite long-standing evidence and discussions. This reluctance to acknowledge these arguments and the insights from natural sciences remains puzzling. In 1982, Jean-Philippe Lauer, a supporter of the stone theory, gave Joseph Davidovits 2 fragments of pyramid blocks, challenging him to prove their artificial origin. Chemical analysis conducted in 2 independent laboratories unequivocally confirmed the concrete hypothesis. Davidovits presented these findings at the Congress of Egyptologists in Toronto. However, Lauer, who attended the forum, did not stay for his colleague's presentation. He merely commented to the press that the idea was implausible. 2 years later, in 1984, Davidovits requested permission from the Egyptian Antiquities Authority to conduct research at the Giza pyramids. His request was denied. The reason given was that his hypothesis was a personal view not supported by archaeological and biological facts. This refusal seemed arbitrary, as no concrete counterarguments were presented. It indicates that Egyptologists might fear that discussing this topic could lead to significant issues. In 2006, American scientists conducted an independent study on the material of the Cheops pyramid blocks. Spectral and mineral analyses showed that the material consisted of a mixture of limestone, sand, and clay, leading experts to conclude that it resembled concrete. Despite this, traditional science maintains a firm stance against this idea. Davidovits didn't just write books, he demonstrated the feasibility of constructing a concrete pyramid with materials available to the ancient Egyptians. He showed how the appearance of the pyramid blocks could vary depending on the composition of groundwater affected by climate and weather. Despite his efforts, it seems modern Egyptologists are intent on preserving the narrative created by their predecessors in the 19th century, a narrative of millions of Egyptian slaves toiling for decades to build colossal structures. This story has been deeply ingrained through extensive writings, films, and textbooks. Admitting it to be a fiction now would be difficult for historians, even when faced with evidence to the contrary. The reluctance to acknowledge mistakes is indicative of numerous errors within the accepted history. Our analysis of Egyptian history and chronology reveals that what Egyptologists defend rests on very shaky foundations with many fundamental errors. Textbooks claim that Egyptian civilization is ancient, existing thousands of years ago. However, there is surprisingly little real evidence supporting this. Thus, the question of how the pyramids were built is not the only or even the most critical issue. The stubborn adherence of traditional science to a potentially incorrect version raises doubts about other aspects of ancient Egyptian history and who built the pyramids and why.